of 3.3, like what we just talked about on the board, we were talking about increasing and decreasing functions. This ties very nicely into what we're going to be talking about right here, because wherever a function, whatever it is, goes from increasing to decreasing or decreasing to increasing, you're going to have a high point or a low point. And that's what this is all about right here. So relative maxima and minima. So these are relatively high and relatively low points. I would say right here on the third floor, aren't we on a relatively high point? Think about it. To get here, didn't you have to go up some stairs at some point? Yeah. So your rate of change was positive. And then later on, at some point, aren't you going to go back down some stairs? So your rate of change of height would be negative. So you went from increasing to decreasing. This is a relatively high point. This doesn't mean that this is the highest point in Valor. It doesn't mean it's the highest point in the state or the world or anything like that. It just means it's a relatively high point. Okay? So these relative maxima and minima will always occur at the same kind of place, critical numbers. There we go, or critical points. And critical points are locations where the derivative is blank or does not exist. You guys get to interact on this? 0. There we go. So the first derivative test, this is one way of discovering and justifying relative extrema. This is one way of doing it. We'll look at a second way later on. So the first derivative test is essentially what you think it would be. It's a testing of the first derivative. It's saying, what is the behavior of the first derivative? Does it go from positive to negative or negative to positive, or does it not change signs? And what does that all mean? So we're going to be testing out the first derivative. Not the second derivative, not like the original like f of x function. We're going to be testing out the first derivative. So if you look up ahead here, there are 3 parts to the first derivative test, and all 3 parts depend on this right here. C has to be a critical number. Of course, critical numbers are places where f prime is either 0 or doesn't exist. So all of this is about a critical number. So here is the first part of the first derivative test. If f prime changes from positive to negative, then f has a relative maximum. And I want to just again draw your attention to the graph here. This is a graph of f. So right here, what would you say about f prime? F prime is positive. F prime is not increasing at all. Actually, f prime is decreasing, to be honest with you. F is increasing, right? But f prime is decreasing. But the more important thing for us is that f prime is positive. So please don't get decreasing, increasing, positive, negative all jumbled up. They all have important meanings, but they're not all the same thing. They're related, but they don't mean the exact same thing every time. And then over here, on this other part, what could we say about f prime? It's negative. And you can see from the graph of f, can you see right there, doesn't it have a relatively high point? Mm-hmm. And so there's a relative maximum because f prime went from positive to negative. Now over here, this graph of f prime, this actually goes perfectly with the graph of f, doesn't it? If you think about it over here, f prime, right here, what could we say about f prime right there? How do we know that f prime is positive right there? It's above the x-axis, that's right. And that's a graph of f prime, that's not a graph of f. So we want to get really good at reading graphs of f, or graphs of f prime, or even graphs of f double prime, and understanding the significance of those graphs relative to f. Does that make sense? And then over here, on this little part, we can say that f prime is negative because f prime is below the x-axis. So what I could do, and I'll just come right out and say it, what I will do, we'll do it here today, is I would give you a graph like that I just boxed in orange. I would give you a graph like that, a graph of f prime, and then say, where does f, not f prime, where does f have a relative minimum or maximum? Make sense? You'd have to look at f prime and say, what's the behavior of f prime? Well, look, f prime is 0 right there, and f prime changes from positive to negative, therefore f has a local max. Make sense? Okay, so that's the first part of the first derivative test. Second part is really similar to it. It's just the reverse pattern. So instead of f prime going from positive to negative, meaning a relative max of f, you've got f prime going from negative to positive. Since it's the reverse pattern, you get a local min. You can see that here. that f prime goes from negative to positive or from negative to positive. But ultimately, based on that pattern, you can see that f has a local min right there at 2. And you can see that that same pattern occurs over there on the f prime graph. You can see that when f prime of 2, when you're at that point, f prime of 2 is 0, and f prime goes from negative to positive. You can see that on both graphs. So you'd want to be, well, and can I just be really honest with you? There is a 0% chance that I would ever give you this graph and say, what's the local min of f? I will never ask you that. Because you just look at it and you're like, oh, that's a graph of f. The local min of f would happen at 2, 0. It requires no calculus ability whatsoever, right? Probably a relatively with it 6th grader in pre-algebra could answer that. Does that make sense? And so I'm not trying to test those skills. I'm trying to test your skills as a calculus student. So please don't have hope that I would ask that question, because I won't. I just simply won't. Okay. And then finally, the last piece of the first derivative test is here. If you've got a critical number, f prime is 0 or doesn't exist, yet f prime doesn't change signs. It doesn't go from positive to negative or negative to positive, then you don't have a max or a min. It's neither. What you end up having is an inflection point. I know that is one of Mr. Kirchner's favorite words. Chapel is an inflection point? Yeah, okay, some of you are paying attention. So look right here. There's a graph of f. Can you guys see? I did my best with this. Can you see right there that the graph of f appears to flatten out for just at least one point? And so right there at that little point, we could say that f prime equals 0. So that's a critical number, right? That's a place where f prime equals 0. It's a potential maximum or minimum. But then look what happens to the left of that. Couldn't we say that f prime is positive? And to the right of that, couldn't we say that f prime remains positive? So even though we do have a critical number it looks like it's at 1, got a critical number there, f prime to the left and the right stays positive, right? F prime does not change signs. That means you've got neither a max nor a min. And you can see right there, there's not a max or a min. That's not a high point or a low point. It's just where the graph kind of bends and then bends back up. So you can see the graph of f prime over there. Can you see how right there, isn't that representing a critical number of f? That's where f prime is 0. But then if you look at f prime, do you see how f prime is positive there and positive there? Therefore, there is no sign change in f prime, so there is no max or min, making it what we will call an inflection point. Okay, so that's sort of the quick version of the video, but to me it's an important one. I wanted to give you a second touch point on that. Okay, now of course there's the other one, but it's still just an inflection point. Question, Josiah?
So there was a question like this on a test or quiz where you'd say something like, find that this is either a relative minimum or maximum of, and you give us the f prime graph, maybe the, I don't know, we'll just do that one. You have the f prime graph, and then you're asked to find maybe just the critical number at that, because you know.
Okay, so let me write this. Hey guys, you should probably be paying attention. Josiah's question could be yours. So you're saying, I gave you that graph of f prime, like that one over there, and you're saying find critical numbers of f?
Yeah.
Okay.
I'd say on the other page, there's probably better examples.
Okay.
How would you want us to graph or say there's a relative minimum at this point? Would you say just at the x value, or would you want a y value?
Oh, the x and the y value?
Yeah.
Yeah, so typically it's going to be in a situation like this, it's going to be worded in such a way that I'm only looking for the x value. Because if I've given you a graph of f prime, if I haven't given you some other information, it's going to be impossible to know what the y value would be.
Yeah.
Sometimes what people will do is they'll say, so let me give you a good example of this. So let's say this was the question, find the critical number of f, right? And somebody says, okay, critical number of f is at the point 1, 0. So somebody would put that? Well, half of that is right and half of that is potentially wrong. Which part is right? The 1 is definitely right. So x equals 1. We can say unequivocally that when x is 1, f prime is 0. But do we know that the y value of f is 0 when x is 1? We don't. We do know that the y value of something is 0. What is that something? When x is 1, something is 0. F prime is 0, right? F prime is 0, but we don't know that f is 0. So like 1 comma 0 indicates f, right? Yeah, no, you got it. So this is kind of, I think, getting at your point, Josiah. I would just say, you know, if somebody said, what's the critical number of f? You'd say, well, it happens when x equals 1. The truth is we don't know what the y is. If I gave you some more information and you guys knew how to do integrals, you could also give the y. But even once you do have those skills, I don't know that I would ask that question all that often, not, at least not in this sort of scenario. Just from a time perspective, you have to dedicate a lot of time to that question. It'd be a good question, but yeah. Maybe I'll think one up and throw it at you guys when the time is right, just to see if you can put it all together. It'd be a good put. I mean, we're talking second semester, probably. Yeah. Okay. Good question. Anybody else? Question or thought? Okay, let's do some examples then. Let's take a look here at our first example, number 1. So we're going to be working on skills with, basically the calculus and the algebra, as well as the kind of the justification or give a reason for your answer type skills. Okay, so I'm going to talk you through this one, give you guys a chance to kind of process this a little bit. So it says, find the critical numbers of f. So it's kind of scaffolding this and giving us a chance to do this little step by little step. If I'm going to find the critical numbers of f, I need to know what those are. Critical numbers of f would be where? Say again? F prime is 0 or undefined. Yep. So if I'm going to try to find out where f prime is 0 or undefined, I probably should find f prime first. Quick power rule, we would get f prime equals 3x squared minus 12x. Take a quick look at this like we've always done. Is there any x value that would cause f prime to not exist? It's just polynomial, so we don't have to worry about that. But of course, it's possible that there's an x value that would make f prime 0. So we're going to set this equal to 0. How do we get to the business of solving this? What would you do first?
X.
Say again?
Factor out an x.
Factor out an x, yep. So x, parentheses, 3x minus 12 equals 0. Do the algebra 2 thing, set each factor equal to 0. And we get x equals 0 and x equals 4. Good? Any questions at all? So we've used this tool before, and we're going to use it here again. It says apply the first derivative test to identify all relative extrema of f. The tool I'm talking about is that sign chart. We did this when we were talking earlier in 3.3. So what I'm going to do is do a little number line and write f prime there, indicating that I'm going to do a sign chart for f prime. And what I want to do is I want to put both of my critical numbers on there in the correct relative locations. So something like that will get me what I want. What I've essentially done here, like before, is I've created some intervals. How many intervals have I created? 3 intervals, right? So there's essentially negative infinity to 0, 0 to 4, and then the last one would be from 4 to infinity. So with these 3 intervals, f prime is either going to be positive or negative for the entire interval, because 0 and 4 are the only places where f prime was 0, right? And so these are the only potential sign change places for f prime. You need to check these, okay? Don't just assume that the signs will change when you want them to change. You need to check these for sure. A number of ways you can do that, but do check. So let's test out some values here, give ourselves some evidence for our reasoning. What number would you plug in for that interval right there? Fair enough. So f prime of negative 1 makes a lot of sense. When you do f prime of negative 1, what do you get? $15. Yes, sir. So what I'm going to do is just put a little plus sign up there, indicating that for that entire interval, f prime is positive. You can assume, and in some cases you'll be right, in some cases you'll be wrong, that from 0 to 4, f prime is negative. But like I said, some cases you'd be right, in some cases you'd be wrong. Let's check it out to be sure. What would you plug in for x for that one? 2, okay. Any number in there should work. What's f prime of 2? It's negative 12. Yep. Give a specific number where possible. It's very possible here. So it did change signs. And then finally for that last interval, would you guys do a 5? Okay. So f prime of 5 equals what? 15. Yep. Some beautiful symmetry.
What would happen if we got f prime of whatever equals 0?
So if you did a test value and you got 0, that means a mistake was made. Either there was a critical number that you didn't find, or you made a mistake calculating your test value. One of those two things has to be true. So go back and double check your f prime equals 0 and make sure you didn't forget maybe you forgot the DNE concept for f prime and you just luckily guessed that number. But yeah, that means you either didn't find all the critical numbers or you made a little arithmetic error. Good question. Anybody else?
If we have a DNE value, how would we put it on the sign?
Where f prime is DNE?
Yeah.
Just put it on there like any other critical number.
Okay.
Yep, just like any other critical number. And just test each side of it.
Okay.
Okay, Nick, question?
So I did F was a big one and then F was one on either side of it and then found that one was.
I'll come check it in just a second. Let me be really clear about something. This kind of looks like this, what you're talking about. It is not required that you show a sign chart at all. In fact, like an AP reader is explicitly instructed to ignore sign charts. So I will too. I will just ignore a sign chart. I think a sign chart is a valuable weapon in your efforts to, get to a good conclusion, but that's not a conclusion, right? Make sense? So like kind of what you were showing me, like I didn't look at the details, that looks reasonable.
Okay.
Very much. Yep. Okay, so we want to draw a conclusion. Yes, sir. John.
So is it required to switch from increasing, decreasing to increasing, or can it be like
Now what's increasing and what's decreasing?
the intervals? Like can the interval be backed up increasing to increasing?
What's increasing?
The f prime of x.
So f prime being,
I mean like f of x increasing.
okay.
So it'd be positive f prime of x.
You're saying that f prime could go from positive to positive?
Yeah, could it do positive positive?
Absolutely. That would be neither a max nor a min. It would be an inflection point.
Plus, minus, minus on that thing.
You could? Absolutely possible. Yeah, please don't be mistaken that it'll always be this nice sign change, sign change, sign change. It could be plus, plus, minus, minus, plus, plus, minus, minus, plus. It could be all kinds of different patterns. It really could. And I'm not just saying, oh, just be aware, but it'll never be that way. It will be that way at times, for sure. So yeah, good question. Good question. Okay, so we got to conclude this, right? It doesn't say justify your answer, but I'm going to do that anyway just so we can get some practice. I would say something like this. F of x has a local or relative max at where? At x equals 0, that's right. Okay, let's talk about why. So this is the give a good reason or justify your answer. Because f prime changes from positive to negative at x equals 0. Now I've already established that x equals 0 is a critical number. I want to be really clear about this. I've already established that x equals 0 is a critical number, so I don't have to repeat that. But if for some reason I had not established that x equals 0 is a critical number, I'd probably want to say, well, f prime of 0 is 0. I'd want to say, hey, this is a critical number, and look at the sign change pattern. But as it stands, because I've already shown this right here, I don't have to repeat myself. Over there on the right would be good reasoning. Let me point out, can I point out something that would be really bad? Really bad in the sense that you know what you're doing, but you just said it really bad, and you'd lose points. That's really bad, isn't it? Isn't it terrible when you know what you're doing, you know what you're saying, but you just write it bad? Check out, everybody look really carefully what I'm about to do. I'm going to erase a couple things. See what I erased? If I replace those two things with this word, now I'm about to use some really foul language, so please don't be offended. In math, that's really bad language, right? Really, really poor language. Let's talk about why. It has a local max because it changes from positive to negative. If you were really reading this critically and saying, okay, I'm really trying to decide, does this person know what they're talking about? Wouldn't you have to ask the question, what is it? Because isn't the answer to what is it make all the difference here? If you were just to say, it does this because it has this pattern, I would look at this and I'd say, I don't think they know what they're talking about because they're saying it for both things. So I'd say that might mean the same thing. So it, I could reasonably say that it might mean F, but if the it means F and then later on the it means F prime, that's confusing. Please never, ever use that word in a situation like this. Please never say IT. Name it, right? How offended would you be if I kept on referring to you as boy or girl or person or human? You know, Caitlin raises her hand. I've got a question. I'm like, yes, human. Oh, boy. Person, you have a question. You like at first you'd think, well, this guy is fairly odd, but whatever, it's this, idiosyncrasy. But you'd be offended after a while, right? You'd say, I have a name, my name is whatever, and you're not naming it. Okay? So please, please, please give the respect due to these people, these concepts, and name them. Now the other one would be this. You'd say f of x has a local minimum at x equals 4 because f prime changes from negative to positive at x equals 4. So it's the same concept, just backwards, right? This backwards pattern. Yes?
F of x changes signs at, f prime of x changes signs at x equals 0 and x equals 4, therefore f of x has local extrema at x equals 0.
No, so that's a good question. You always want to be specific. You always want to say local min, local max. So you're right. You do have local extrema there, but be specific about is it a min or a max. The fact that f prime changed signs does mean, yeah, there is a local extrema, but you want to be specific as to what kind of local extrema. And so, Matt, I mean, the AP test is written that way. If they say find the local extrema, and it's an open response, you're supposed to write it out. If you just say the local extrema are here and here, they want specifics. And so usually on my test, I'm going to be really explicit. I'm going to say find the local min, find the local max. Use the first derivative test to justify. I'm going to spell it out exactly what I want you to do. They're a little bit less specific because they figure by the end of the year you should be used to that. Be specific with mins or maxes. Yeah. Good question. Okay, so let's take a look at one more here. We have about 3 minutes left, right? I can't remember what time this class ends, but we'll get there at some point. Okay, so take a look. This next one will actually be relatively quick, I think. Nope. Let's do this. Let's do number 3. We'll come back to number 2 later. Guys, hey, let's take a look at number 3. Number 3 is pretty different from number 1. In number 1, what did I give you? What did I supply you with? Come on, be specific. What kind of thing did I give you in number 1? An equation for f of x, right? What am I giving you information about here in number 3? A graph of g prime. So not a graph of g, but a graph of g prime. So if you think back to the first derivative test, like that outline it was in the video, the thing we just went over a few minutes ago, this is kind of like that. I've given you a graph of g prime, but then I'm asking you about the relative extrema of g. So let's remind ourselves, if g has a local max, then g prime will do what? Go from positive to negative, but if g has a local min, g prime will do what? Go negative to positive. This, of course, has to happen at critical numbers. So let's take a minute here and look this over. What are the critical points of g? Nice. Negative 3, 1, and 4. How do you know that negative 3, 1, and 4 are critical points of g? That's the zeros of g prime. That's right. So here, here, and here. Those are all locations where G prime is 0. Because I got a graph of G prime, you can see right where it crosses the x-axis or touches the x-axis. We're going to have critical points there. Okay, so we can actually go straight to our concluding comments from there. But I'd say this: G of x has local maxes at x equals what and what? He's right. Do you see it? -3 and x equals -4. Because, let's talk about the because. I would say this, please don't pack up yet, I still got 2 minutes. G prime of -3 equals G prime of 4, and they both equal 0, so they're critical numbers. We haven't really established that yet as to why those are critical numbers. So I'm going to write, hey, G prime of -3 and 4 are both 0, and G prime does what? Changes from positive to negative. You got it. So we'll say something like this. Changes from pos to negative at those points. You want to establish, if you haven't already, that -3 and 4 are critical points of G. That's where G prime is 0. And you see the sign change pattern from positive to negative in G prime. And then the other one, yeah.
So, like on the last question, when you find the derivative of it and set it equal to 0, does that...
That's in lieu of that statement right there, right? Because we've already
suffices?
proven it. Yeah, but you don't have to do it twice. Yep. And then, of course, you could say G of x has a local min. Where? At x equals 1. Because, be careful, there's no f's in here at all. Because G prime of 1 is 0. And G prime does what? Changes from negative to positive. Yep. Okay. So that's it for today. We will continue with this pattern of working on 3.3, I think, for most of the rest of the week. Have a great day. Happy Monday after break. See you guys.
Sad.